Okay. You guys all got your calculators out ready to go? Yep. All right, so we've multiplied and divided, right? So now today we're going to add and subtract. Remind me, I'm going to skip down here to where it says multiplying and dividing. When you multiply and divide, you do or do not need like radicals? You don't. You do not need like terms in order to combine them. What about 2x times 3y? What do you get? Everybody good? What about, I don't know, that's good enough, right? Multiplying? Okay. What about when you're adding and subtracting? You need like terms. You must have like terms. For example, 4x squared plus 8x squared is what? 12x squared. Now I want you to notice something. The x squared didn't change at all, did it? All you did was add or subtract the numbers that were in front, the coefficients. Is that okay? The same is true for radicals. So, when we are trying to add and subtract radicals, you must first try to simplify. Can you break it down? Remember when we do that, we're looking for pairs, right? Okay. You must have like radicals to combine. Meaning, you can only add radical 3's with other radical 3's. You can only subtract radical 5's with other radical 5's. If they're not the same, you cannot put them together. You just leave them separate. Good? When you do add and subtract, you are only going to add or subtract the coefficients. You will not do anything with the radicals. You're going to leave them like they are. Just like with that x squared that I just showed you, we're going to leave the x squareds the way they are. Everybody A-okay? All right, so let's take a look. Number 1. Do you see how it says simplify to give an exact answer? If you were to type this in your calculator, actually, let's do this. Ready? Grab your calculators. Ready? 4, the square root of 7, close the parentheses after that 7, plus 5, the square root of 7, close the parentheses after that 7, and press equals. You get a huge decimal, right? It is not exact. So we're going to keep the radicals in there to make it exact. Sound good? Okay, so are they like radicals? They are, which means you can put them together. So if I have 4 radical 7's and then I add 5 radical 7's, how many do I now have? You have 9 radical 7's. Notice the radical didn't change. Are we good with that? That's it. Number 2. You're not going to make it radical 14, no. Is that all right? Okay. Number 2, are they alike? They are. So all I need to do is take and subtract 8 radical 11's minus 2 radical 11's, and that gives me 6 radical 11's. Now you'll notice there, it wouldn't make any sense to subtract them because if you did, that would just be 0, right? So it doesn't make any sense. Okay, now I can combine adding and subtracting. So if I take 6 radical 2's and add 9 radical 2's, how many does that give me? 15 of them. And then if I subtract 18 of them, negative 3 radical 2's. Questions? Pretty good, right? It's all good and gravy as long as they match. And this one doesn't. So I ask you, what parts of this can I put together? The radical 14's, right? I have 8 of them, and I subtract 5 of them. What does that give me? 3 radical 14s. Now, does that plus radical 3 get to go with anybody? So what do? We drop it down. Just like you would do if it was a variable. Does that make sense, everybody? Can I show you something before you go on? Some of you are already going on to the next ones. Just wait a second. I want to turn these into variables to show you how this works like variables work. These two would be able to go together, right? What would you tell me? And this one doesn't go with anything, so what would I do? Drop it down. Do you see how this is correlated? Correct. Okay, so that was just an example. All right, take a look at number 5. What can I put together there? The 17s. Now that says 3 radical 17s minus 9 radical 17s. Negative 6 radical 17s. 5 radical 13s. Do you think it matters the order in which I put those radicals? No, I could also write it with the minus 5 radical 13 first, and then the minus 6 radical, minus 6 radical 17. Everybody okay with that? We sure. So what about number 6? Break down the 48, because they don't match as they are, right? But you know that 48 can break into something, right? Look at all the other numbers we've done so far. The only other number up here that would have broken down is 14. And what does 14 break into? And that's it, right? Which means I have no pairs, which means it's going to stay the same anyways. Okay, so how about that 48? 4 and 12, okay. So those are done. Okay. Okay. Wonderful. Everybody doing all right? Okay, so do I have any pairs? 2 and 2. Which, can I just go straight to the 4 for everybody? And what's left underneath? And then I'm going to drop down that plus radical 3. And now they match, don't they, folks? Now, what's in front of this radical 3 over here? A 1. So if I put them together, what do I have? Wonderful. Good. Pretty good? Okay. All right, what do you think about number 7? Okay, and how are you going to do that? Okay, 8 and what then? 24, you said? Okay, where are you going from there? Okay. 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 So, before I start this, what was out front to begin with? A 5. So I'm going to start with that. Now, do I have any pairs? 2, a 2, and a 2, right? 2 and a 2 and a 2. 2 times 2 times 2. I think I'm going to write it like this, and then I'm going to say 8 radical 3. Is that okay for everybody? Oh, but it's not 8 radical 3. What is it? 40 radical 3. Good. Okay, and now I'm going to drop down the minus 7 radical 3. Do they match? Great. So we're going to combine them. And what's that give me? Did I hear 33 from over there? Notice, again, I'm not changing the radicals. After I get them to match, they stay the way they are. All right, what do we think about number 8? Okay. Into what? 10 and 15. Okay. 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 Looking good. So, what was out front of that first radical to begin with? Okay, do I have any pairs out of the 24? 1 pair of 2s. What's left underneath? a 2, and a 3. So what is 3 times 2? Radical. Good. Everybody doing all right here? Following okay? Yes, no? Okay. How about the 150? Do I have any? Well, first of all, what was out front? A 4. Do I have any pairs? So another 5 comes out. What's left underneath? So what is 4 times 5? Radical. And what's supposed to be in between them? A plus sign. Good. Do you see how once we break them down and simplify it, it all matches? Okay. 26 radical 6. Good. If you mess up the breaking them down, folks, you're going to be in a world of trouble. Good? Right. Number 9. Okay. Okay. So, what was out front to begin with? What else do we have a pair of? What's left underneath? Okay. Everybody following James? He's on his A game today. He's doing well. I like it. How about the 32? What am I splitting that into? Say it again. Okay. Okay, what was out front to begin with? A 10 times, what do I have pairs of? 2 times 2 is 4, right? And what's left underneath? Just a 2? Following? Picking up what we're laying down here? Okay, multiply that. What do you get? And what's supposed to be between them? A plus sign. Do they match? They do not. I will tell you, if I were you, I would check it. Let's do that. Grab your calculators. Are you ready? I want you to type in -9 radical 75. Negative what? Okay, everybody clear your calculators out. Let's try it again. -9, the square root of 75 equals. Everybody getting this now? Okay. Now, clear it out. -45, the square root of 3. Is it this? So we did that piece right, correct? Okay, clear it out. Let's check the other piece. 10 radical 32. Say it again, please. Everybody agree with that number? Okay, and now try this one. 40 radical 2. Same thing? So we did that one right as well? Okay, which means we did something right. We did everything right, really, but they still don't go together. It's not no solution. This is still simplified. You just don't get to put them together. Okay. Oh. How we doing? Fine? Okay. Oh, that's not too bad. Not too bad. All right, what do we got here? Yeah, so what are you going to do? All right. What do you think? Okay, 12 and 36 I got. You can do different numbers, but that's the first one I heard, okay? Now, but this is a good thing because isn't 36 perfect? What is 36 split into? Now, could you break those sixes down? But don't because they're pairs. Okay. So let's leave them like that. How about the 12? 2 and 6, and then nope. There we go. Okay, so what do I have pairs of? pair of 2's, and a pair of 6's. So 2 times 6, what's left underneath? Okay, and then what would you get when you multiply that? Everybody okay with 12 radical 3? Are you sure? Okay, now let's go to the 300. 50 times 6. Okay. 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 5 and what? There we go. Okay, so what do I get out of there? So 5 times 2 with a 3 underneath. What is 5 times 2? And then the radical 3? What symbol should be between there? Okay. Last portion of this one. 24 times 8? Wait a second. Didn't we already do 192? Didn't we? Right here. So don't do it again. But remember here, this 5 came from out front. Does that make sense, everybody? So 2 times 2 times 2 is 8 radical 3. Plus, right? Okay. Can they go together? They can. 12 minus 10. 2, right? Plus 8. 10 radical 3. Good. Everybody A-okay? Okay. Number 11. What do you think about the first portion of number 11? Why? It's done. I can't break down 3 any further. Now, didn't we already do 75? Where is it? Right there? Now, that negative 9 was from out front, correct? So what am I going to have? 5 radical 3. Oops. Now, there's already a 2 out there, isn't there? Does everybody see that 2 from the beginning of the problem? Yes? So what do you get when you multiply that? 10 radical 3? So final answer? Good. It's okay if you want to work smarter, not harder. But you have to remember what was out front and all of that stuff, okay? I don't think we've done 32 yet. Oh, we did? Let's see, where is it? Right over here? Number 9. You all see how this 10 was from the beginning of the problem? It's 4 radical 2. Is there anything out there? A 3. So I have 3 times 4 radical 2, which is 12 radical 2. Have we done 63? Not today anyways. Okay, so what about 63? 3 and 21 will work. You also could have done 9 and 7. How about the 21? Okay, so what comes out of there? And there's already a 4, right? What else is left underneath? A 7? How's everybody doing? You sure? Okay, what is 4 times 3? So negative 12 radical 7, and I still have that 12 radical 2 from the first part, correct? Can you put them together? Now, why did I put this problem in here? I tried to trick you. The 12s match, but it doesn't matter if the 12s match, right? The radicals have to match. So we're good there. Questions? All right. 28, break it down for me. Okay. Whoops, I don't want to circle that one. So what gets out? And there's already a 5 out there. What's left underneath? Okay, so 5 times 2 is radical 7. How about 45? Five times 9? What's up? What are you putting? Oh, I thought you were 5 times 9, and then the 9 is what's already out there to begin with. It's a perfect square. Yeah, so see how it broke into 3 and 3? It's giving me those pairs. That's okay. It's good to recognize that, though. There was a 2 already out there, agreed? What else is coming out? A 3, and what's left under? A 5. So 2 times 3 is radical 5. So it's going to be a minus right here. Good. Not like radicals. Questions? Okay. What do you think about number 14? You love it? 4 and what? How about the 4? Okay. So there was already a negative 11 out there. What else is coming out? A 2? Good, sir. And what's left underneath? Oh. Are you good? Okay. Oh, yes, it was not circled, though. Okay, so this will be negative 22, William says. Radical 2. How about the 12? 4 and 3, or 6 and 2 if you wanted. Okay, so what was out there to begin with? Okay, what comes out? Okay, so, and it's a negative. But you still have to simplify them, guys. Okay? Okay, you do the last one. Good? Yeah? Got it? So how many radical 13s do you have? Put them together. This one goes with this one. Good, I'm glad you said 10, because remember, there's a 1 in front of here. Okay. Questions for me, folks? You sure? Okay. Homework. Okay.